We often remember Thomas Edison as an inventor. It's a convenient word, but it's also incomplete. You see, Edison didn't approach engineering as a search for some kind of elegant universal truth. He saw it as a problem of dominance. Not dominance over nature, but dominance over systems. Think about it. By the late 19th century, electricity had already proven it could work. Scientists and engineers knew you could generate it. You could make it do things. The real question, the one that truly mattered, was no longer asterisk if asterisk power could be generated, but asterisk who asterisk would control it. This is where Edison's genius, or perhaps his particular brand of it, comes into play. He understood something that most of his engineering peers completely missed. A machine by itself doesn't create power, a system does. So, Edison didn't waste his time trying to build the single best, most perfect device. No, his focus was far more strategic. He concentrated on building devices that simply could not function outside of his network. Take his famous choice of direct current, or DC. This wasn't because DC was technologically superior to alternating current, or AC. In fact, in many ways it was inferior, but it was chosen because it was containable. Direct current meant low voltage. It meant short range. It meant predictable behavior. Electricity that couldn't travel very far was electricity that had to stay close to his generators, close to his meters, close to his ownership. From a purely mechanical perspective, this might seem inefficient. Why limit yourself? But it wasn't inefficiency. It was strategy. Edison was designing an entire ecosystem where every single component depended on all the others. His generators, his specific wiring, his meters, and of course, his light bulbs. Each piece worked acceptably on its own, sure, but they only worked optimally when they were all together as part of his system, and that system was under his control. This wasn't an accident. It was a core belief. Edison believed that systems should be closed, that any complexity should be centralized, where he could manage it. He believed power should remain legible, measurable, and limited. He fundamentally distrusted anything that behaved freely, anything he couldn't pin down. And that's why alternating current, AC, was such a threat to him. It wasn't dangerous just because it was supposedly unstable. That was mostly a PR campaign. It was dangerous because it escaped AC, could be transformed to high voltages, transmitted over vast distances, and then stepped back down. It could be detached from its source. From Edison's perspective, this was pure chaos. A system that couldn't be geographically constrained, couldn't be economically contained. So when we look back at the so-called War of the Currents, it's easy to see it as a technical debate between DC and AC. But Edison wasn't really fighting a form of electricity. He was fighting a loss of control. His famous laboratories, like the one at Menlo Park, weren't just workshops in the way we might imagine an artisan studio. They were industrial command centers. Problems were brought in, broken down into their smallest parts, and then solutions were tested relentlessly around the clock. Failures didn't matter as much because they were absorbed by the sheer scale of the operation. Edison didn't need perfection in any single component. He needed dominance of the entire system. He was willing to tolerate mechanical inefficiency. What he could not tolerate was economic inefficiency. In Edison's world, engineering wasn't about what asterisk could asterisk work, in theory. It was about what could be asterisk enforced asterisk in practice. This philosophy shaped every single design choice he made. Those short transmission distances of DC power, they meant you needed more power stations, closer to the customers. More stations meant more infrastructure. More infrastructure meant more capital investment, and ultimately, more dependency from the cities and consumers who bought into his system. And that was the real product: dependency. Edison didn't just invent the light bulb. He invented a system that made light inseparable from ownership. In doing so, he revealed a completely new role for engineering. Not as a force of liberation, but as a tool for containment. He showed the world that the most powerful invention isn't a device, but the system that makes it indispensable. So the next time you flip a light switch, think about that. You're not just using a simple device. You're participating in a system, a network of control and dependency designed over a century ago. Edison's true legacy isn't the bulb itself, but the invisible grid that powers it. A grid built on a foundation of strategic containment. It's a powerful reminder that behind every great invention, there's often an even greater and far more complex system at play. The rivalry between Thomas Edison and Nikola Tesla is one of history's great dramas. It's usually framed as a clash of egos, a battle between a showman and a visionary. But that story, as juicy as it is, misses the real conflict. This wasn't just about two brilliant men who disliked each other. It was a war between two completely different philosophies of engineering, two opposing visions for the future of civilization. The real story isn't about personality, it's about power. Not just electrical power, but the power to control, to own, and to shape the world. To understand this, you have to think like an engineer. Edison's entire approach was built on one core idea. He envisioned a world where every city block had its own little power station, churning out direct current, or DC. His systems were designed to be predictable and contained. Think of it like a series of connected gears. Everything is tightly linked, mechanical, and direct. If you want to power something over here, the source has to be right over there. It's a closed system. The problem with a closed system is that it doesn't scale well. With Edison's DC, the further the electricity traveled, the weaker it got. The energy loss was massive. Every new extension, every added wire, was like adding friction to the machine. It made the whole system less efficient and more expensive. So why would a genius like Edison build something so limited? Because that friction, that limitation, was actually a feature, not a bug. It created barriers, and barriers are how you maintain control. If your power can only go a few blocks, you own those blocks. You have a captive market. Then along came Tesla. His vision was the complete opposite. He believed power should move freely, unconstrained by distance. His masterpiece, alternating current, or AC, was designed to do just that. AC was revolutionary because it was transformable. You could crank the voltage way up to send it over hundreds of miles with minimal loss, and then step it back down to a safe level for use in homes and factories. From an engineering perspective, this was a breakthrough. It was an open system. It prioritized scalability over local control. Tesla wasn't just improving on Edison's idea, he was tearing down the walls Edison had so carefully constructed. To Edison, this wasn't progress, it was chaos. It was an existential threat to his entire business model. This is where the infamous War of the Currents really kicks in. The public spectacle of Edison, electrocuting animals with a C to prove how dangerous it was, that was never truly about public safety. It was a desperate marketing campaign born out of the fear of losing architectural control. Edison knew that if power could travel freely, if it could be generated in a remote location and sent anywhere, then no single company could own it completely. The grid would become decentralized. Ownership would fragment. From a business standpoint, this was a nightmare. From an engineering standpoint, it was the logical next step. This is the moment where engineering becomes permanently entangled with economics. Edison wasn't just inventing things, he was inventing business models. He understood that machines weren't just tools to get a job done, they were instruments of leverage. His true lasting legacy isn't the light bulb or the phonograph. It's a method, a philosophy of design that has shaped our world in ways we barely notice. The Edison method is this: design systems where the alternatives are impractical. Design them so that the cost of switching is too high. Design them so that dependence feels like the natural state of things. Think about it. This is the playbook for entire industries that came later. Early telephone networks were built so they couldn't easily connect with competing networks. Software platforms are designed to lock you into their ecosystem, making it a pain to move your data elsewhere. Even your printer ink cartridges are a perfect example of the Edison method. He was one of the first to see that the most profitable system is unto ways the most efficient one, but the one that creates the most dependence. In mechanical terms, you could say Edison built locks, Tesla built flow. So, who won? It's tempting to say Tesla, right? After all, the world runs on his AC power. But it's not that simple. History didn't just pick a winner. It did something much more interesting. It absorbed both philosophies. We live in a hybrid world. We have Tesla's physics operating inside Edison's systems. Power flows freely across continents, just as Tesla dreamed. But our access to that power is tightly controlled by a handful of companies. Energy is scalable, but the distribution network is owned. You pay a bill to a company that holds a monopoly over your area. That's Edison's ghost in Tesla's machine. This is Edison's real, enduring triumph. He demonstrated that the most powerful form of engineering isn't just about building better machines, it's about engineering human behavior. It's about designing the very architecture of our choices. The most dominant designs aren't necessarily the strongest or the fastest. They are the ones that define the rules of connection for everything else. They become the standard, the platform, the system that you have to conform to. Thomas Edison didn't just build machines, he built cages. Beautiful, functional, and incredibly profitable cages. And whether we're talking about our energy grid, our software, or our communication networks, we are, in many ways, still living inside them. The story of Edison and Tesla is a timeless lesson. It teaches us that whenever we look at a new technology, we should ask ourselves two questions. First, what does it do? And second, perhaps more importantly, what does it want us to do? The answers to those questions define the world we live in. Thanks for watching. If you found this interesting, consider subscribing for more deep dives into the ideas that shape our world.